Hey guys, let's do this review real quick on the video so you'll have something to study about for the last test before fall break. Okay, f of g of -2. First of all, you take the -2, make sure I got a color, and plug it in the function g. So that's going to look like, make sure you use parentheses here, -2 squared minus 2 times -2 minus 6. You work all that out, 4 plus 4 is 8, be 2. Now you take that 2 and plug it into function f. So I'm going to do f of 2. And I'll put the 2 in the function f, which is right here. 3 times 2 plus 1, 6, 27. There's your final answer right there. So remember, work backwards. It's kind of like working backwards there. It's called composition. Number 2, h of -3. So I'll take -3, plug in the function h right there. So if I do h of -3, I get -27 when I cube -3. Now, then you got to plug -27 in. So I'm going to do -27 into h, which would be -27 cubed. Everybody knows that is 19,683. Piece of cake. Number 3, g of f of 5. Again, working backwards, I'm going to plug the 5 into function f, which is going to be f of 5 would be 3 times 5 plus 1, which is 16. Then take that 16, plug it into function g, which is going to look like g of 16 would be 16 squared minus 2 times 16 minus 6. Punch all that in if you want to, and you're going to get 218. All right, keep going. Number 4, find f of g of x and the domain. So because it says f of g of x, I'm going to take function g and plug it into f. So that function is going right there. So I'm going to go the 5th root of x plus 2 to the 5th power minus 2. What happens when I do that, a 5th power of a 5th root, they just cancel. So I get x plus 2 minus 2, which gives me x. Okay, that's the first answer. Then it's set in the domain. The way you do domain for a composition, remember, is you do the domain of the second function, the g. In this case, because it's an odd root, it's all real numbers, and compare it with the result, which is x, which is also all reals. Because they're both all real numbers, the domain is all reals. I'm going to write it like that. You could also go with the big R. Lots of ways you could do that. Number 5. Now you got to come up with two functions here that will give you this function. So you need to write an f of x and a g of x. And you need to come up with two functions that will work if you were to do f of g. So I'm thinking one good way to do this would be like to go x cubed for f of x, and my g of x be 2 minus 3x. Therefore, if I were to do f of g and put my function g into f, if I put this in there, it will look just like that, which means I know I got it right. Let's keep going. Determine visually whether the graph is symmetric with respect to the x, the y, and the origin. Number 6 is definitely symmetric with the y-axis. Number 7, x-axis for sure, y-axis for sure. And if it's the x-axis and the y-axis, remember, that means origin automatically, so you got origin there. Number 8, tell algebraically which one is which. So what you need to do to tell the y-axis symmetry is plug in a negative x. If I plug in a negative x, see if I get the same thing. I will get a negative 3x minus 2y equals 3. And that's not the same thing I started with, nor is it the opposite that I started with. So that's no y. Let's try x-axis. To try x-axis symmetry, I'm going to plug in a negative y, where the y is. And I will get 3x plus 2y is 3. Is that the same thing I started with? No. Is it the opposite? No. So that means there's no x-axis symmetry. Then to try origin, I'm going to plug in a negative x and a negative y. And ask the same question, see if we get the same thing there. So that's a negative 3x. That's going to be a positive 2y. Is that the same thing? Nope. Is it the opposite? Almost, but the 3 messes it up. So long story short, number 8 is there is no symmetry whatsoever. Let's try number 9. Same exact steps. You need to show this tomorrow. Plug in a negative x. I'm checking for y symmetry right now. And if you square a negative, it becomes positive, so that's still the same function. And it's because it's the same, it means it does have y-axis symmetry. To try for x-axis symmetry, to check for it, plug in a negative y. See what happens here. If you square negative, it becomes positive again, which again is the same thing. So it has x-axis symmetry. And remember, if it has y and x-axis symmetry, automatically has origin. I'm not going to check that. You can just go ahead and put origin symmetry. Does the graph of number 1 represent an even or odd function? I forgot what number 1. I think it means number 6. Yeah, it means number 6. There was no graph of number 1. Let's go with number 6 there. Number 6, because it's symmetric with the y, that means it's even. Remember, just like it's a parabola, even a parabola is x squared. You know how that goes. So even. Number 11, to tell whether this function is even or odd. Now, to check even, that means y-axis symmetry, which means you plug in a negative x. Now, to be honest with you, up front, I'm noticing that it has odd exponents, which means it's not going to be even, but I still got to show algebraically. So what I'm going to do is I'm going to plug a negative x in wherever I see an x, which is there, and also there. And because the exponents are odd, it stays negative, which means that's going to be a positive 3x cubed and a negative 2x. That is not the same, and it's not the exact opposite, so it's not even. Now, it could be odd. To check odd, you got to plug in a negative x and a negative y. If I plug in a negative y, I get negative y. Negative x, I already know it's going to look like that, so it's going to put the 3x cubed minus 2x, because I've already worked that out. And I'm looking at this right here. I'm looking at that, and I'm asking myself, is this the same thing as that, or is it the exact opposite of that? And it is the exact opposite of that. And because it's the exact opposite, it has origin symmetry, which means it is odd. It is odd for sure. And number 12, determine how one of these can be taken from the next. Okay, remember all those gestures we did. The 5 is inside. Remember that shifts your graph left or right opposite of what you think. So I'm going to put shifts left 5. The next one has a negative in the front, so it reflects across the x. Reflects across. Remember, don't write flips. X-axis. Also, the 2 in the front, it's a vertical stretch by 2. Good stuff there. And number 14. 14 has a 1/3 in the front, which means it is a vertical shrink by 1/3. And also shifts right 3, because it's the 3 is inside and it's left or right, opposite of what you think. The 1/3 is a number in the front, less than 1, vertical shrink by that number. 15, write 1, where you have y equals x squared. So that's what you're starting with. This is it's reflected across the x, which means you got a negative in the front. It's got a vertical stretch of 3. You have a 3 in the front. Shifted right by 4, so the 4 must be inside, and it's opposite of what you think. Then the square goes there because it was an x squared graph. Love that problem. And number 16. 16, inequality here. Start off by subtracting 1 from all 3 sides. That's going to be a negative 4 over here. Inside's going to be negative 2x. That's going to be a 2. I'm going to divide everything by negative 2. Because I'm dividing by negative 2, all the signs flip. So that's going to be a positive 2 over there. That's going to be a negative 1 there. So really my answer would be negative 1 to 2. Bracket around the negative 1, parentheses around the 2. 17, write slope-intercept form of the equation. There's both parallel and perpendicular to that line right there. That line, first of all, the slope is 2. So if I'm doing parallel, I'm doing the same slope. So I'm going to go y, I'm using this point. Y minus 6 is 2 times x plus 1. So distribute the 2. Move the 6 over. If I move that 6 over, it'll be a plus 6. This is going to be 8. There's part A. Part B, perpendicular, same setup. Except instead of using slope 2, use the opposite reciprocal. So change the sign and flip it. So I would distribute the negative 1/2. And then just move the 6 over. So I get negative 1/2 x. If I move that 6 over, it becomes plus 6. I'm going to do 6 times 2, which is 12, minus 1, which is 11 halves. And there's the answer to part B. 18, given that f of x equals that, find f of a minus 3. All you do here is plug the a minus 3 in for all the x's, so you get a minus 3 squared. Please use parentheses. Oh my gosh, be so careful. This is not hard work, but if you don't use parentheses, it can really mess you up. Square multiply double square here. That's how I got that. Distribute the 3 there, and then add what you can, which is going to be nothing. The a squared is by itself. The 3a's, you're going to have a minus 3a because of those. The 9's cancel. This leaves you a minus 4. And there's that one. And the last one, number 19, find an equation of the circle. Now, when you start circles, remember you got an x with a square plus a y with a square, and it's going to equal the radius squared on that side. The center is what goes inside the first 2. And remember the opposite. We just did that yesterday, the opposite of what's inside. So 2 is going to be a minus 2. Negative 5 is going to be a plus 5. And why does it pass through that point? Because it works. So I'm going to take that point, that 4, put it right there. Take the 5, put it right there. 4 minus 2 is 2. 2 squared is 4. 5 plus 5 is 10. 10 squared is 100. If I add 100 plus 4, I get 104. And guys, that's all the red right there. That's the answer. That's your equation. All right. Hope this helps. Please, please, please use it to study by. Last test tomorrow. Do great. Finish strong. See you tomorrow.